Hello, everybody, and welcome to the very first inaugural video that is published here on the Data Governance Playbook. Today, I want to start with a foundational concept that's really about data as an asset. And I want to kind of talk about like how you can really conceptualize that, like how you can think about data as an asset and how that can help you explain data governance and data management concepts, because they really also talk about, treating data as an asset and how to kind of, take care of them, curate them, and make sure that you're driving, good impact off of them, and that you're driving a positive return on your investments and your efforts. With that, let's start with the foundational concept, like where we're starting the analogy here, which is really about real estate, right? So if you think about real estate and what maybe a manager of a portfolio of real estate might do is they might own a portfolio of buildings such as the ones in this picture, right? It could be, an apartment building, there could be a couple of houses, maybe there's a train station, but the general point being that there are investments into buildings and you're trying to make sure that you're driving a positive return on those buildings. Now, the analogy that we want to continue to draw in the remainder of this video is to do the same for data assets. So you want to consider, an organization or a business unit or a division to at times be a manager of assets, data assets, and in that sense, you're also trying to drive a positive return on these assets. So this page is the one that we'll use to continue to take different kind of components, different elements to follow this analogy further to explain, what data governance and data management really are about, which is to, again, drive a positive impact based on those data assets that you have. So we're going to start at the top left and we're going to make our way down, and then to the right of the page, and then again, make our way down. And so we'll start first with, the property of the building, right? It's really the core, part of the analogy here. The building, the property, that's what you can compare to the data asset, right? The data asset can be, a table, various table, kind of a cluster of data that is being used for a variety of usually reusable purposes. That's where we start this analogy. Now, the second part of the analogy is the owner or the landlord. So if you think about really any building, right, any piece of real estate that exists out there, then somebody tends to own it. Like somebody tends to be, the owner of that, or if it's kind of a house that is being rented out, it could be a landlord. A similar concept exists in the world of data management, namely you have a data owner, or more, I think, acutely, the right comparison here would be a data product or a data asset owner, right? So if you have, let's say, a database of customer data, like that database could have an owner. And in a similar way, that owner would be trying to look after that database and try to drive a positive return on it. Now, if you think about back to the real estate example, so the third component of the analogy here is the property manager. If you think back to, people really hold a big portfolio of real estate, right? Or if it's a really big building, it tends to be the case that the person who owns the actual property is not the one who has time, maybe even expertise to actually manage that property. And that's where a property manager can come in. And so in my own case as well, like in my past, I've rented out my house when I was actually abroad. I didn't have time, potentially neither the expertise to manage it. And so there was a property manager who's kind of doing this work on my behalf. Even though I own it, the property manager was the one who was doing kind of all of that work. So in our analogy, in our example of a data asset, that's actually pretty similar to a data steward role. Like a data steward has more time on their hands than a data owner. And they can do a lot of tactical work. They can help look after the building. If there's something wrong with it, they can kind of help step in to fix it. They can help drive, knowledge and advertisements about this data asset or about the building. So a data steward is somebody who really tends to know the property really well and is really able to kind of in a very operational day-to-day way, look after that particular data asset. So then if we go to the next one, tenants, the next component in this framework of sorts, tenants are the people who live in or make use of the building. So if you think about a house, it could be a family who lives in that house. If it's a bigger, commercial building, maybe it's a company that is using it for a given purpose. If you compare that to data assets, like that would be the data consumers and data users, right? If you think about that consumer database or the database of consumer data, customer data, like who would be the users of that data? Like who would access it, go into it, and then kind of retrieve that data and use it for different purposes, right? That's kind of the analogy, the equivalent that you can find in the data asset world. Then if building is being used by somebody who is not also the owner, then there tend to be rent payments involved or lease, right? So that's like if you live in a house, you pay rent because you live in somebody else's house, but you use it. That's not like data monetization, right? Data monetization is where you let people use the data, but you charge them for it, right? So that might be most applicable for data that you have, and you actually let other people outside of your organization potentially use it, and then you sometimes internally as well, and then you charge them back for it. The next one here, which relates to this lease and rent payments in some way, shape, or form, because it's usually referenced on it, is the lease agreement. So if you use a building, if you sign anybody who's ever signed a rental contract, you know that there's a lease agreement there, and it says in there things you can and can't do. It may say things about you subletting it out to yet somebody else, very often not allowed. It sometimes says something about you may or may not be able to have pets in there. A similar, let's say, concept exists in the data asset world, which is namely a data contract. Like the fact that you're giving access to somebody to a data asset doesn't mean that they can just use it for whatever, right? For any purpose. Like a data contract, which can actually be used both externally with other companies as well as internally with people within your company, specifies what the data is that can be used and for what purpose, usually. The next component here is the building price. So anybody, again, who owns a house has probably a rough idea about what that house is worth. And there's actually a fairly well-established way that you can price houses and buildings out there. We're very far removed from being able to do the same for data assets, but we're making a lot of progress here. And this is really where it comes back to the earlier concept of data monetization, but also about like value quantification. So, we take the same example that I mentioned earlier about a database of customer data, like what's the worth of that database? Like how much, if you have a very clean data asset that provides information with correct names, correct dates of birth, correct emails, maybe correct preferences, etc. Like for a lot of companies, we all know it's very valuable, but how valuable exactly? If you didn't have that, how much money would you not be able to make because you no longer have that data to act on? There's some really interesting use cases out there. Back during COVID days, United Airlines actually used their Mileage Plus loyalty program, and specifically the customer data that was in that loyalty program as leverage underneath the loan that they got. It's like a very real way that a data asset was given a price, or at least a value. Then the next component in this framework is the cameras and door locks, or in a general sense, kind of the security of a building. So this, almost anybody who has a house, I'm sure you have a lock on the front door, back door. If you aren't living on the ground floor, some of your windows might also have locks on them. A lot of people have Ring doorbells or other sort of cameras that you can use to keep an eye on your house or your property when you're there, when you're not there. It just helps to kind of protect it, make sure that only those people who you want to give access are the ones that are actually able to access. And even if somebody does access that shouldn't be accessing them, that you can take appropriate action. A very similar concept exists in the data asset world, which is really the data security and access controls, right? It's really about being able to monitor, almost having a camera of sorts on on the entrances of to your data asset, like who's accessing them. Can I track and trace who that is? And is that somebody that I would expect that data usage or the data asset from access from? Next component here is about building architecture. So anybody who has maybe like me in their backyard tried to like throw some slats of wood together with some nails knows that that might not result in the most solid of structures. And for any building, it holds that. If you have a construction company who's building a skyscraper or an airport, even just a regular townhouse, they don't just start from scratch, right? They really think through what do we build, in what order, what are the foundations, how thick are the walls, how do we make sure that the upper levels are supported by structures in the lower levels. All of that is translated into a building architecture. Now, something similar exists in the data assets world, which is namely a data architecture, right? That's the same way. Like, you don't want to just immediately start drag and drop and dump data in a given place just because you can, right? You want to make sure that a lot of things are maybe set up before you actually do that. And we think about data architecture, that could be, the platform itself, there could be storage capacity, that could be, backup capabilities so that if something happens, data is still available. It could be a prescribed data model. There could be all sorts of architectural components that make sure that when you actually start building the data asset, that it's structurally sound, right? It is ready to do what it is supposed to do. Then the final one on the left-hand side of this image is the HOA neighborhood. So a given building might sit in a HOA, homeowners association, or a given neighborhood, which kind of says that for the most part, you share some similarities, some shared purpose, maybe some shared usage, some commonalities, shared infrastructure perhaps, with the people or with the buildings in your neighborhood. That's really what HOA neighborhood are all about, for the most part, right? And HOA goes a step further than kind of a general neighborhood, in the sense that they tend to have certain rules that what you can and can't do in your neighborhood. So a data domain is maybe a similar concept, in the sense that if you think about a data assets, like there are in some way, shape, or form other data assets that are typically part of the same data domain. So if you think about a data domain like customer data, there may be several tables and clusters of data that have capture different parts of customer data, right? Some of them might identify the individuals. Some of them may be about contact data. Other ones might, capture preferences again. Like these might all be subdomains within a broader data domain. Other data domains could include product data, finance data, human resources or employees data. It depends a little bit on the company and the sector exactly what the relevant domains would be. Then if we go now to the top right of the page, we see zoning laws, building code, fire code, environmental regulations, all sorts of examples of basically rules, requirements, laws that must be complied with for your building, for your real estate property. Depends on the country, depends on the type of building. Sometimes it depends on where they are, depends on how old they are. Sometimes it depends on the material you're using, but they all have certain explicitly identified rules and requirements that you must abide by. And if you do not, you may be punished. And so from a data asset perspective, that's not unlike data policies and standards and regulatory compliance. Regulatory compliance is usually where external rules, laws are active that would apply to your given data asset. So again, the earlier example we had was a database of customer information, in which case privacy legislation such as CCPA or GDPR or other ones might apply. That is, they are active in given regions of the world, and that might be parts of regulatory compliance that might apply to your given data asset. Data policies and standards are kind of the internal rules and requirements that are compiled for within the company to define the expected standards and behavior for how different data is being managed. Typically here as well for data policies and standards, there's different rules and requirements that may apply depending on what kind of data it is, what is it being used for, nature and sensitivity of these data, in a very similar way as I had mentioned earlier around for buildings, depending on the type of material you use, what is being used for, where the building is located, that's when different things kind of kick into action for a given data asset. Then if we think about property specifics, if you think about if you are if you truly are like somebody who manages a portfolio of real estate and you kind of go beyond 1 or 2 buildings, but you really go from like 10 to 15 to maybe 100 buildings, then it becomes even more important that you have certain specifics available. I mean, it's already very critical if you're trying to really sell or rent out one particular building, because you must be able to talk about how big is it, how many square yards or meters are in there, when was it built, who are the previous occupants, perhaps, what are appropriate uses, all these types of things, maybe distance to the next airport. There's all sorts of specifics that you may want to have for any given individual building, but even more so if the portfolio starts growing and you might not have them just, committed to memory already. Like that's not unlike metadata. Like metadata, which, the common definition is data about the data, can really be about that. Like, what is this data set? Like, what kind of data is in it? Who owns it? What are the different attributes that are in this data asset? What's appropriate usage? What's maybe the sensitivity level? What's the owner? Who's the appropriate steward or architect associated with a given data asset? All of these are examples of metadata. Then the property condition. So if we think about a building here, then it may be in a really perfect state. It might be deplorable and not being looked after in quite some time. And so that's no different for a data asset. Right? A data asset can have higher or lower quality. There's all sorts of capabilities that companies have invested in to actually be able to identify, define, measure and then enhance data quality for the same reason as you would for a building. Like if you have a building and you don't do anything to it, then everybody knows what's going to happen after 10, 20, 30 years. Like it's going to be dilapidated. It's going to not be looked after, and the quality is going to go down, and the value is going to go down to zero. And to keep up that condition of the property, you can have building cleanup and maintenance. Kind of the next element of the analogy here. If something happens, if the roof has a leakage, if there's also just debris in hallways or in different rooms, like if you don't clean that up, then eventually it's going to affect the value of the building. Similar is the case for data asset. And so that cleanup work, right, whether it's like really structural fixes, like you're fixing a wall, or you're fixing an elevator, or you're fixing a roof, or more like spot cleaning and keeping the hallways clean by vacuuming those, both of those have their equivalents in data remediation. So in data remediation, like structural fixes, fixing the roof or fixing the elevator, that could really be about, making sure that a given column in a database now has updated specifications about what appropriate values it can hold. Data remediation can also be that a data flow that is going into your data asset is fixed because it was allowing kind of unclean data to come in inappropriate formats, for example. But you can also have more operational day-to-day remediation, which is really about just cleaning things up. Like as data assets or as buildings are being used, like every once in a while, you may want to take a broom and sweep the hallway. Also, that is part of data remediation. Then the occupation rate. So this has to do with, if you happen to have an apartment building in your portfolio and you have 100 rooms in there or 100 apartments, like you would like to see how many of those are being used. And if it goes, I'm not an expert in real estate, but I can imagine if it drops below a certain number, a structural occupancy less than 80 or 70 or 60% or something like that, like, something's wrong. Why is it low? What can I do about it? Data usage may be similar in that way. Like you would like to track who's using your data for what purpose. Some of those purposes could relate to the earlier mentioned data security and access controls. But some of it is also about like being able to identify and quantify value, right? How many people are using your data asset, and across different teams, across what regions, like having information, actionable information on this, occupation rate of sorts for your data asset can be very valuable if you're trying to establish a business case for why it should continue to be looked after. Then the next component of the framework here is common infrastructures and resources. So here you can kind of think about, let's say, the water that comes into the house or the electricity. Like if you build a new house in a given neighborhood, like you don't, I mean, sometimes if you're building out in out in nature, you might make a decision to, create your own water well and like pump up your water, and you may, have your own solar panel or something like that. But very often you want to tie into common infrastructure and resources, because otherwise you're reinventing the wheel and you're being very isolated. And so that's kind of what is being called or referenced as interoperability for a data asset. Like you want to make sure that as much as possible you use common infrastructure and resources, because it drives the interoperability. It drives how easy you're able to exchange data with, let's say, other teams, other systems in a given context. Examples of interoperability could be interoperability standards, like where you specify, for example, which type of data model we use. A data model, in this case, you can almost interpret like a language, right? So that if a certain system has data in a given format, that another system for same type of data is using similar type of language or similar type of model, so that no interpretation or data quality work is needed before they can use the same type of data. That's what interoperability is about. Then the next one on the bottom right is property size. So if you think about buildings, like this could be the number of floors, square meters, cubic meters, number of rooms, not unlike data storage. Like data storage can include information about how much data is in there, how many terabytes or whatever the however much data you have, how many attributes are in there, and maybe related to that can be something about like elasticity and scalability, like where for a property building that might be a little bit harder, right? It's not that easy to just scale up and down, like add rooms or floors as needed. In the data asset world, that tends to be more important, to be able to scale up and down as kind of the demand grows for different data assets. Building life cycle, like really relevant for buildings. Like they very often, at some point in the very earliest stages, they're being thought of, a business case is being created, somebody draws up the architecture like we talked about in the very beginning, they're being built, it's being used for an amount of time. Then at some point there may be a lot of remediation that's happening. Eventually there may be some remodeling to kind of bring it back up to standards, or make sure that it continues to be fit for purpose or relevant for a given group of users, or people who want to use the building. And eventually it might be demolished. Data is no different. It is, ideally follows a similar type of thought through life cycle, where you think about, or you kind of have the ideas about what type of data asset you need. You draw up the architecture, it's being built, it's being created, potentially in a test environment first, being pushed to production. Over time, you might have certain updates being done to it. Some of them may be very minor, some of them may be very big, where kind of the whole platform is almost raised to a new standards. And then not uncommon is that eventually you demise it. Like we're doing tons of projects where people are migrating from one environment to another. Some, for example, from on-prem to cloud environments, not necessarily unlike how you can think of a life cycle. And then the last one on the bottom right is about connecting roads and sidewalks. And so this is really about, if it's a train station or an airport or an apartment building or just a townhouse again, you want to make sure you're able to get to it. You want to make sure that there's more, pathways for you to be able to, if people, they might be walking, there might be trucks, there might be trains, but like, how do you make sure that people get to your building? Like you can have the best property building, the most luxurious apartments, grand pool, fantastic parking garage. But if you stick it in the middle of the desert with sand all around it, nobody's going to use it. Like the value is going to be close to zero. Data integration is not unlike that, right? So if you think about how you have a data asset, you want to make sure that you think about how you integrate it into the relevant landscape. And the same thing here is true for in terms of like what kind of traffic you want to be able to, or connections or integration you may want to enable. Like there might be just a big truck that comes, every week, which might just be, a batch file that is being sent or ingested once a week. It might also be the case that it needs to be available all the time for everybody, right? That anybody can just hop in whenever they need to, as whenever the need comes up. So data integration here, you can think about is similar to a building and how you integrate it into kind of its surrounding landscape. And that concludes this example of how you can think of data as an asset and how we compare it to real estate, and how you can think about data assets like a property or a building and how to drive a positive impact and a positive return on that specific asset or product. So that concludes the first video that is going to be published on the data governance playbook. I hope you all enjoyed it. I'm hopeful that many videos will follow, and if any of you have any questions or suggestions, do not be shy and please reach out.